Today is an important day. We're going to look at how to solve maximum and minimum problems. And essentially what we go over now is how you solve every maximum and minimum problem. Let's take some examples. Two positive numbers add to 30. Find the numbers so that the first times the second, the square of the second, is a maximum. So identify what you're looking for. We're looking for two positive numbers. So I'm going to call my first one x and my second one y. What about the fact that they're positive? Don't worry about it. We'll look at that at the end of the question. Now, these two numbers add to 30. Can you write yourself an equation? The entire purpose of this equation is to figure out what y is. So y would equal 30 minus x. And why we care. If this number is x and this number is 30 minus x, we are now got ourselves down to only one variable. When we write an equation, we'll be able to take a derivative. As long as we had two variables, this was going to be really too complicated. Time for the equation. Find out what it is that you're trying to find a maximum or minimum of. So we're finding a maximum of the first number multiplied by the square of the second. That looks like this to me. First number multiplied by second one squared. Now be cautious in this step. There's another way to write this. Does it matter if we change this to our second number and this one to our first number? If we do that, how does that change the equation? The equation would then be the first number times the square of the second. And why do you care? This one looks like we could easily multiply that out, and taking the derivative would be easier. I don't want to expand that, so I'd be left with a product rule involving a chain rule. So keep in mind that you are in control when you write these equations. If you don't like the way something looks, sometimes you can switch things and make it easier. So watch for that. There's a truly magnificent question towards the end, where depending on how you do it, it can take an extra half hour of work to solve the question. So take your time and look at it early on. So again, where did that come from? What we were trying to maximize. We wrote an equation, and now a maximum. What do we know happens at a maximum? The slope of the tangent is equal to 0. So we're going to find the derivative. Again, you are in control. You can choose to do a product rule, or you could choose to expand it first and then take the derivative. Always do what seems like the most simple approach. Time for the derivative. 60x minus 3x squared. Let's make that equal 0. And then I think we're going to factor that. I have a common factor. 3 goes into both of those. X is common to both. When we pull out the 3x, we get 20 minus x. Let's just double check. 60x, 3x squared. All right, what would make this 0 and what would make that 0? I'm getting 0 and 20. Now, just like we did with our graphing, we're going to find out whether this is a max or a min. You're subbing into the derivative. You can put it in here if you want, because we have not changed any plus or minus signs. Easy number in between these would be 1. When I plug in 1, I get positive. 20 minus 1, positive. So positive in this region. To the right of 20, how about 100? 3 times 100 is positive. 20 minus 100 is negative. So this section is negative. And a number out here, how about negative 100? 3 times negative 100 is negative. 20 minus negative 100 is positive. Multiply those together and we get a negative. So we have decreasing, increasing, decreasing. We were looking for a maximum, which is when you increase, then decrease. This point would give us a minimum, and we're not interested. So a maximum occurs when x equals 20. Nice work, us. But what was the question? The question was find the numbers. So we're not done. We have to find out what y equals. So when x equals 20, we said y was equal to 30 minus x. So we'll put the 20 in here. And so y equals 10. All right, so the two numbers are 20 and 10. These are two numbers. Oh, and check that positive. They're both positive. So there, we've sorted that out. And again, you don't really have to worry about that till the end. So the two positive numbers adding to 30, dealt with that. And when you multiply the first one by the square of the second, that's when you get a maximum. For those who are saying, why can't I just answer y equals 10 and x equals 20? Why do I have to write words down? And here is the answer to your question. Imagine I ask you a question such as, how old are you? And you tell me x equals 18. That's a very strange answer. Wouldn't you tell me I am 18 years old? So the same thing, I've asked you a question. Find me two numbers. So you would answer, the two numbers are, as opposed to x equals 20 and y equals 10. Let's try a different one. A rectangular field is enclosed by 600 meters of fencing. What dimensions will produce a maximum area? I think I'm going to draw a picture for this one. So we always want to organize our information or organize what we're looking for. Last time we were talking about two numbers, so we wanted x and y. This time we have a field, so we'll draw a picture. We could call the sides x and y. Rectangle means they have to be different. And why don't we just keep labeling the sides? We know we have 600 meters of fencing. So this is our fencing. So this fencing plus this fencing plus that fencing plus that has to add up to 600. Our goal again when we did this was to know what y is. So let's just simplify this equation. We could divide everything by 2. When we do that, we've got x plus y equals 300, and then we could take the x to the other side. So y is equal to 300 minus x. And again, the entire purpose of doing that is so that we get ourselves down to one variable. When we're working with x and y, pretty nasty to find a derivative. Working with one variable, much more simple. Always look then for what we're trying to maximize or minimize. And the answer is area. So area, we know, is x times y. All right, so area x times y, and y was equal to 300 minus x. Maximum slope of tangent equals 0. So we're going to take a derivative, and I choose to multiply out first, because I would like to avoid the product rule. Now let's take a derivative. And what you should be finding is that once you've set up the problem, the rest of the work isn't bad at all. Take the derivative, let it equal 0, bring the 2x over, or divide by 2 first. We could do it in that order. And then bring the x over, so we know x is 150. We have to make sure that this is a max, and it just didn't, we just don't take the number we're given. We're going to make sure it works. Plugging into the derivative. We can plug in here because we have not changed any signs. Nice easy number on this side is 0. That would be positive. Easy number on this side, 200. And that would be negative. So what does that do for us? Increasing left, decreasing right. So yes, we do have a maximum. So maximum occurs when x equals 150. What was the question? What dimensions? So the dimensions, we would like to know the values of x and y. So x is 150 and y was 300 minus x. So plug in 150 and we get 150. All right. So the dimensions that produce a maximum area is 150 by 150. So quick recap, we drew a diagram, put variables on, wrote an equation involving this. Sole purpose of that equation was to find out what y was. Look for what you're trying to maximize or minimize, write an equation for that, take the derivative. Feel free to simplify before you do that. Set your derivative equal to 0 and solve. Once you've solved that, put that on a plus minus chart so we verify it is indeed a maximum, and then answer the question. Let's try something different. Determine the number that exceeds its square by the greatest amount. Determine the number. So we only want one number. So I'm going to let my number equal x. So my number is x. We want it to exceed its square by the greatest amount. So we're going to let that equal something. I could call it d for distance if I wanted to, or just y. What does it mean to exceed something? We could think about age. My age exceeds yours, and if we wanted to find out how much it exceeds yours, we'd subtract. So to find out how much something exceeds, you subtract. So the equation, the distance between these two numbers, is the number x minus the square of the number. Nothing to simplify, so we go straight to the derivative, set it equal to 0, bring the 2x over, divide both sides by 2, and get an answer of a half. Oh, this is making a little more sense, because up until now you might have been thinking, but x doesn't get bigger than x squared, but it does with fractions. So between 0 and 1, if you have the number 1/2, and you compare it to its square of 1/4, the number is actually bigger than the square. Oh, maybe this makes sense after all. All right, let's check our plus minus chart. 1/2, we're plugging into the derivative. Nice easy number on the left is 0, plug that in, I get positive. Easy number on the right, 1 minus 20, definitely negative, increasing, decreasing. So that will give us a maximum when x equals 1/2. What were we supposed to do? Determine the number. Looks like we're done. So the number that exceeds its square by the greatest amount is 1/2. So really, in many ways, every question is done the same way. Write an equation. If you have more than one variable, you're going to have to write an equation and figure out what that variable is in terms of x. Find out what it is that you're trying to maximize or minimize. Greatest amount, that tells you maximum. There's our equation. Take a derivative. Make it equal 0. Solve it. Put it on a plus minus chart to find out if it's a max or a min, and then answer the question. It really is the same procedure every time. What's different will be the equation. And that is where the fun comes in. So your job today, we're starting lesson 4. There's a lovely collection of max min problems to keep you occupied for a while. Off you go. Have fun.